So in this lesson, we're going to talk about how we can use the trigonometric ratios, sine, cosine, and tangent, to solve for missing sides in right triangles. In order to do that, we're first going to have to talk about how we can label the sides of a right triangle. One thing you're hopefully familiar with is the hypotenuse. The hypotenuse is always opposite the right angle, and it's always the longest side in a right triangle as well. So opposite or across from angle C, we have the hypotenuse. Now, depending which angle I'm working with, I also have what's called an opposite and an adjacent side. So assuming I'm working with angle A, if we look directly across from angle A, we get the opposite side over here. So this side over here is the opposite side. Okay? It's not touching angle A in any way, it's across from it. And then finally, beside angle A is the adjacent side right here. Think of adjacent kind of meaning like beside something. If you sit adjacent to someone, you sit beside them. This is beside the angle. So we've got the hypotenuse, the opposite, and the adjacent side. The sine of angle A is the ratio of opposite divided by hypotenuse. The cosine of angle A, or COS for short, is the adjacent divided by the hypotenuse. And finally, the tan of angle A, which you may have already looked at, is opposite divided by adjacent. You can see that SOH CAH TOA is a way of remembering which ratio is which. So sine is opposite over hypotenuse, cosine adjacent over hypotenuse, and tangent opposite over adjacent. So just to review, remember what this means. This means that if you have an angle A, the sine of A tells you what the opposite divided by hypotenuse, what it must be, okay? The tan tells you what opposite over adjacent must be, and the cosine tells you what adjacent over hypotenuse must be. No matter how large the triangle is, okay, this angle A will determine what the ratio of these sides must be equal to. So for example, I might be talking about the sine of 30 degrees, which is actually exactly 1/2. So if sine 30 is equal to 0.5 or 1/2, that means that if you have a right angled triangle where the angle is 30 degrees, then the opposite side divided by the hypotenuse must always be 0.5, no matter how big the triangle is. Or another way of looking at it is the opposite, since the opposite divided by the hypotenuse is 0.5, it means that in a right triangle with a 30-degree angle, the opposite side will always be half the hypotenuse. Of course, as that angle gets bigger than 30 degrees, well, then the opposite divided by the hypotenuse is a larger number. In our class, we looked at the tan ratio already, and we talked about wheelchair ramps and how the bigger the angle is, the greater the rise over run of the ramp is. And so tan of an angle A gets bigger and bigger as the angle gets larger. Let's look at how we can use these ratios to solve some problems. Okay, so here we've got a triangle with an angle of 31 degrees. And we have the hypotenuse, that's 15, so that's the hypotenuse. And then across from the hypotenuse is the opposite side. This is the adjacent side. Okay, so we want to solve for side H here. What trigonometric ratio could we use here? Well, opposite, if we think of SOH CAH TOA, we're solving for the opposite side. So we need a ratio that involves the opposite side. So clearly we're not going to use cosine. It doesn't have the opposite side in it. Now we have the hypotenuse. So we actually want to use sine in this case. And the reason we want to use sine is because we want to include the variable we're looking for and a side we know. We can't use tan because we would talk about H and adjacent, and we don't have either of those sides. So look at part B. When I set the equation up, that also helps explain why I'm going to use sine. The sine of 31 degrees is equal to opposite over hypotenuse, which in this case is H over 15. And this gives me an equation with only one unknown, the H value. Sine 31 degrees is just a number, okay? And so I can solve this equation for H, okay? What you want to do next is figure out what the sine of 31 degrees is. And as you do that, do make sure that your calculator is in degrees, not radians, RAD, or gradians, GRAD. make sure that it's in degrees. You should find sine 31 degrees is about 0.515. Okay, and now we need to solve this equation. 0.515 equals h divided by 15. Now you have two choices here. You can multiply both sides by 15 to get h equals 15 times 0.515, or if you like, and I know a lot of people do like this, they always like to cross multiply. Put it over 1 and cross multiply. In either case, you're going to get that h times 1, or h equals 15 times 0.515, which gives us an answer of approximately 7.7. Oops. About 7.7. And that is in centimeters. Okay, looking at the next one here, we're looking for x in this case. Now notice that x is opposite the right angle. So here we actually are looking for the hypotenuse. Okay, 64 degrees is the angle we're working with. Across from 64 degrees, okay, is the opposite side. And that makes the 9.7 the adjacent side. Okay, remember the opposite side is always opposite the angle that you're working with, or the angle that you're given in this case. So which trig ratio do I want to use to solve for x? Well, x is the hypotenuse, so not going to be using tan here. Cosine or sine? Well, if I use sine, I've got opposite over hypotenuse. Those are both unknown sides, so that's not going to be very helpful. So the answer is that we want to use cosine. Okay. We do that by setting up an equation. Cosine of 64 degrees is equal to, adjacent over hypotenuse is 9.7 divided by x. The next thing I'm going to do is I'm going to figure out what cosine of 64 degrees is using my calculator. It's about 0.4384 to 4 decimal places, equals 9.7 over x. Again, I'm going to put it over 1 here so that I can cross multiply and solve. Okay, so I get 0.4384 times x is equal to 9.7 times 1. Okay, this is an equation. Imagine you had something like, 4x equals 20. You would divide both sides of the equation by 4 to get 5. X equals 5 is your answer. So in this case, we're going to be dividing both sides by that 0.4384, which will give us an answer of 9.7 divided by 0.4384, which is about 22.1 centimeters in this case. Makes sense. The hypotenuse got to be larger than 9.7. It's always the largest side. Okay, here I put it over 1 and I cross multiplied. Okay, and that's how I'm getting this equation that I solved. Okay, you could also, sometimes you get to the point too where you can just kind of remember that that's what you do when your unknown is in the denominator. It always means you're going to divide. But I like this idea. Figure out what cos 64 is, put it over 1, cross multiply, and do it that way. Okay, looking at question 4 here, we're solving for the unknown value in each triangle below. And the unknown value, they mean the variable. So in the first one, 4a, we're looking for z. Notice z is opposite the right angle, therefore it is the hypotenuse. Now 12 is actually it's opposite the angle we're given. So it's actually opposite the opposite side here because it's across from the 49 degrees. If we were dealing with the angle in the bottom right, then it would be the adjacent side. Now the angle in the right here is 41, so you could actually work with this angle. I'm going to work with the 49 though. And finally, this side here must be the adjacent. So in this one, we want to include the hypotenuse to calculate it, and we want the opposite side. So this is a sine question. The sine of 49 degrees is equal to 12 over z. Now when I use my calculator, I get so for the sine of 49 degrees, 0.7547 equals 12 divided by z. To solve that equation, I'll put it over 1 and I'll cross multiply. and I'll get 0.7547 Z equals 12. Divide both sides of that equation by 0.7547, and you're going to get the answer of 12 divided by 0.7547. Okay, it's a 7 there, which gives you very close to 15.9 meters. Okay, looking at part B here, we've got 71 degrees. We've got 34 feet, which is the hypotenuse, since it's opposite the right angle. Across from 71 degrees is the opposite side, and then beside we've got the adjacent. Okay, well, I can solve for either A or B first. Let's assume that I want to solve for A first. Adjacent, so I'm going to need a ratio with the adjacent, and I'm going to need a ratio with the hypotenuse, so that I only have one unknown. That's cosine. So the cosine of 71 degrees is equal to A over 34. Okay, using my calculator, the cosine of 71 is about 0.3256. And then again, I can solve this equation. You can either put this over 1 and cross multiply again, if that's what you like doing, or you can just multiply both sides by 34. In either case, the answer is going to be whatever 34 times 0.3256 is, which is very close to 11.1 feet. So there's your answer for finding side A. Now, how about side B? You've got a lot of different choices here. You could use the sine ratio to solve for B. You could use the tan ratio because now you have side A, or you could use Pythagorean theorem since you actually have two sides you're looking for the third. It doesn't matter which you do. They're all going to be close to the right answer. I'm going to use the Pythagorean theorem. C squared equals A squared plus B squared, where C is the hypotenuse, 34 squared. Okay, A is 11.1 squared, and I'm looking for B squared. So that's 34 squared is 1,156. 11.1 squared is 123.21. Okay, just run out of room here. We're actually not going to do this question today. We're not going to worry about this in this lesson. Okay, so next, if I'm solving for B squared, I know that 1156 take away 123.21 equals B squared. So that gives us a B squared value of 1032.79, and then finally we need to take the square root of that value to get the answer. Which gives about 32.1 feet for B. Okay, keeping in mind there are lots of ways to solve for side B. We could have chosen to use, like I said, sine or tan, and we could have done that before we solved for side A. I chose to use Pythagorean theorem just to remind you that when you're dealing with trigonometry, don't forget Pythagorean theorem is still something you can work with. Question 5, we'll worry about that in class. I'm not going to worry about that right now. And there's some questions for you to try right here. And that's it for this lesson. Thanks.